Hey everybody, looks like some of you are already here waiting. Cool, cool. I'm just gonna get set up here. You all should be glad that you had my mic on mute when I was doing that stretching and neck rolling. That was some pretty awful popping. So, does anybody have any questions about what's going on right now? All right. Well, if you have questions during the presentation, then please, like if you would like to ask a question vocally, then please use the hand raise, and I'm going to try to operate it that way. If you want to ask a question via chat, then ask a question via chat, and one of the instruction team will ask it for you. Looks like we're getting our first host. Hi, Jacqueline. How's it going? No problem.
Oh, there it is. There it goes. Oh, it's great. How are you?
Very good. Glad to see you.
Yes.
So thank you so much for coming. I think maybe we wait for Emily until we kind of do the whole order of how things are going to go down. But are you feeling like you kind of know enough about the class and what's going on?
I think you should wait for her. I think.
Okay.
Yeah, because she will. I bet she's in approximately the same place I am in terms of knowledge. So.
Awesome.
Yeah, I was just getting my book out, getting ready.
Right. And nothing like a little open book test, right?
That's right. It's your book. That's the worst. I was in a podcast once where they were asking me questions, and they're like, "Well, what did you say the solution was when you have a stakeholder who's ineffective in your chapter? What did you say about that?" And I'm like, I can barely remember it. I wrote I felt very embarrassed not being quizzed in my own book and failing the quiz. But
yeah, we've all been there. You know, at a certain point, you think, I wrote that? I've definitely found that in things I've written 5 years later. So just, I want to quickly address a student question in the chat. Michelle, I think that the 300 person limit has been fixed. As far as I understand it, the department managed to fix that for us. So our Jacqueline, our last guest lecture setup, we had I'd never had every single person show up to a lecture before that. And since our lecture is a 385 person one, we apparently broke Zoom. So
I didn't realize that was a limitation. I never even thought about it. That's so funny.
Yeah,
well, I just came in. You broke Zoom?
Yes, we the last guest lecture we had we have a 385 person class, and in general for any of the things I've done, I haven't gotten every single student every single time. So I never found out about the 300 person limit until Monday. But yeah, we are theoretically fixed now thanks to the Department of Cognitive Science, who has given us an upgraded license. But all you students out there, if any of your friends are messaging you saying, hey, I can't get in, we've hit the limit, please let me know immediately, okay? I'm not sure if I can do anything about it, but I would like to know if all the promises that they made us that this wouldn't happen again were right or wrong. Okay, welcome, Emily.
Hi, everyone. I'll have my fancy mic soon enough. My husband's currently using it for his webinar. And he gets paid for his. So well, it's his job. He's a bridge instructor.
Mm-hmm. Yeah, that's the sharing of resources in marriages is always a hot topic.
Yes, but he promised to deliver it. He's done in 15 minutes. So then I'll have my fancy mic. I mean, this gets me through all my work meetings, but I see Jacqueline. Do you have your fancy mic below you? Yeah, there you go. Okay, I'll have my matching one soon enough.
Yeah, not that it's a contest.
Well, so far my fancy mic has not failed me, but in a previous lecture, it started doing the 100 microsecond echo. That was really nice.
So Emily and I do a podcast together now, and I'm the one who edits it, and we've done like 8 episodes now, and I've already can be like, Emily, your room has too much echo in it. Throw a couple towels near the mic or something. Like yeah,
but all the rooms have too much echo. Jacqueline and I have talked about this before. So all the rooms are something. There are no.
You know, those that are really dedicated to the craft just take like a giant blanket and wrap it around themselves while they record.
No, I might need to do that for a future episode.
That sounds good regardless of echo. That just sounds very comfortable.
I have saw, so I'm a fan of the Wirecutter, and someone posted how they now have like the best like sleeping bag wearable. So it is like a sleeping bag, except it has holes for your arm. And they're like, this is what, it's pandemic. You want to spend more time outside? Wear a sleeping bag. No one, I don't know how people, in tech, we have casual dress code. I don't know how people who are used to like business casual or business formal are going to go back to doing that every day if they've loosened up in quarantine.
Yeah, I don't know either. Then again, I'm in California where business casual means flip-flops. So
Yeah.
It's like, I'm in Seattle. That's basically the same. Utah, though, I don't know.
Oh, well, I'm referencing New York, where it's definitely like, my dad's lawyer wore a suit and tie every day. It made it easy to get him Christmas gifts because we would just get him a new tie every year, like that had little subtle animal patterns in it.
I remember being in college and thinking, when I go and get a job doing math in the real world, I'm gonna have to wear a suit or whatever. Like be that fancy. I was glad to learn that that's not really how a world works. That was nice.
Do you have your physical copy with you, Jacqueline?
I do. Yeah. I only one time used the Kindle version.
Yeah.
all right. Looks like we're getting there on students. So while people are coming in, I do want to just briefly mention to everybody that what I'd like to do this time is I if we can, to avoid some of the crazy crush on questions, that if you have a question, especially during the presentation, while Jacqueline and Emily are talking, and you feel like something is important and you'd like to ask a point of clarification, please use that hand raise icon that Zoom gives you, okay? And then myself or one of the TAs will do the interrupting and give you an opportunity to speak, all right? If you have questions at the end at Q&A, let's also try to use the hand raise, because it just like there was kind of a crush at the end of the last guest lecture where people were kind of talking over each other. So let's try to avoid that by using the hand raise. Also, if you are somebody who feels more comfortable asking a question in the chat, then go ahead and do that. My TAs, I would love it if you would kind of keep track, keep me honest if I have missed some of the people in the chat. You can do the interrupting in those cases when I'm totally missing out what's going on. Okay. All right, so let's see, we're passing the 3 o'clock mark and we're passing the 240 person mark. So we're getting there. Should we give it just one more minute to see who comes in? Okay, let me give you both co-host access right now so that you can do any screen sharing you're interested in.
Ooh.
All right, you should both be good to go that way. And I'm going to stop my little screen share so that you guys can take over at any time. As soon as I find the button. There it is. All right. So just in general, what I'd like to do, if you guys are good with it, is about on the neighborhood of 30 minutes of you talking and in the neighborhood of 30 minutes of question and answer. Is that all good?
Yeah, that sounds great. Yeah.
All right. Well, let me do just a quick little intro then. I would like to say to everybody how pleased we are that Jacqueline and Emily have come to visit us. So Emily Robinson currently works at Warby Parker as a senior data scientist. And in the past, she's worked at places like DataCamp and Etsy doing various kinds of analytics things. So she has her master's degree in management from INSEAD, which is a pretty cool place. And she came from Rice as her undergraduate in decision sciences. Dr. Jacqueline Nolis is currently a data scientist with Brightloom, which, if I'm not mistaken, is a cool kind of marketing place, but I know nothing about marketing. So she's previously worked at places like DSW and Union Bank, Microsoft, Airbnb. And yeah, so your PhD is from Arizona State University, right?
Yes, that's right. Sun Devil, as they say. Yes.
There we go. So, well, without further ado, I think I will let them get in on it because obviously it's not me you've come to see today. So thank you very much, Jacqueline and Emily.
Thank you.
Thank you.
Yeah, so Jacqueline, Emily, we go around and give talks like this because of, as you saw on that slide, we wrote a book together. The book is just super heavily for people like yourselves who are aspiring to be data scientists, or they have started the data science career and they want to know more about it, how to be better at it, how to get your data science job, things like that. The first half of the book is about becoming a data scientist, getting your first job, writing a resume, doing interviews, negotiating, all that. And the second half of the book is once you are a data scientist and you have a data science job, what does it mean to do an analysis, work with stakeholders, become a manager, all that sort of stuff. And the way me and Emily like to do this is each time we present in front of people, we each choose, together we choose 3 parts of the book that we find interesting that we want to talk about. And so this time, Emily's going to talk about her 2 faves, and I'm going to talk about one of mine. Emily, did I miss anything?
No, and I think just adding on there that it is, it's kind of all the non-technical stuff, because there's a ton, as probably some of you are familiar with, technical resources out there. So I want to learn deep learning in Python. I want to get started in R. But we saw this gap for, as we'll talk about, there's a lot of communication skills, just these other knowledge that you need to be aware of in order to get in and succeed in data science, and just to make it easier. So that's what we wanted to help.
Yes, and I'm going to say it now because I'm going to probably forget later. If you want to go buy a copy of a book, you can go do it at bestbook.cool. That's bestbook.cool, and there's an offer code BUILDBOOK40%, and that's 40% cheaper. Yeah, so Emily, you want to get started? Oh.
Jacqueline has a cat.
I know, I was trying to mute right at the right time, and I didn't do it.
Yes, I'll get started. So the second chapter of our book is called Data Science Companies. And so I wanted to read about one of them, which is, so these are, fake companies, but archetypes, so kind of representing different types of companies you might work for. So this one we called Handbag Love. It's an established retailer, so think like Bed Bath & Beyond, Best Buy. So we start out this section saying Handbag Love is a retail chain with 250 locations across the United States, all selling purses and clutches. It's been around a long time and filled with experts on how to lay out a store and improve the customer experience. The company has been slow to adopt new technology, taking plenty of time before getting its first website and its app. And then a little bit later, we have the pros and cons. By being at Handbag Love, you have a lot of influence and ability to do what you think is wise. You can go from proposing making a customer lifetime value model, building it, and using it within the company without having to persuade too many people to let you run with the idea. This freedom, which is due to a combination of the size of the company and the newness of data science, is very rewarding. You're incredibly empowered to do what you think is best. The downside of this power is that you don't have many people to call on for help. You're responsible for finding a way to make things work or dealing with the fallout when things don't work. The tech stack is antiquated, and you'll have to spend a lot of time making workarounds for it, which is not a great use of time. You may want to use a newer technology for storing data or running models, but you won't have the technical support to do it. If you're not able to set up any new technology entirely by yourself, you'll just have to get by without it. So I wanted to read that excerpt, and we have a couple others. One of them is a massive tech company that we also talk about. Another is an early stage startup. But I think sometimes when people think of data scientists, it's easy to think of developing a self-driving car, or, working at Microsoft, or maybe at like Lyft or Airbnb at a tech company. But there are so many other places and industries where data scientists work, and there are pros and cons at different ones, and there's not one right answer. So at the end of the chapter, we talk about how you can compare different companies. So they might vary on salary, mentorship, the freedom you have, and there's not one right answer. What's important for you might be very different than what's important for someone else.
Yeah, and I think you hear a lot from people who want to be data scientists, and I want to work at Google and Facebook, but it's best to work at a top tech company. But I like working at these kinds of companies more. If you think about every McDonald's, Macy's, Foot Locker, blah, 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 all these companies, they all need a data scientist. And if you are our data scientist there, it's not very hard to quickly become one of the most biggest experts at the company because you have so much access to the data, and you're just such a valuable resource there. It's a really cool job compared to being like a data scientist at Google. But it's also very different because if things don't go well, you have to figure it out yourself. You can't just go talk to any number of other data scientists they have at Google. So it just like challenge your preconceived notions of where you think data science might live. I feel like is a pretty good lesson from that. I guess, Emily, have you worked at a company like this? No.
I have not. So I've worked at like the startup, like the earlier stage startup. It's my last job. And at the, like we have another one called Video Re, which is kind of like the late stage startup. So like 1,000 people or so. So that's around Etsy. I like those too. I mean, I think for me, one thing I enjoy is having a community of other data scientists at the company to talk with, to learn from. So Jacqueline and I have had the kind of debate before about being a first data scientist, which is usually the case if you're joining an early stage startup, and sometimes even a later stage company that may be just getting started with data science. And I think we enjoy talking about that because I'm someone who really is not interested in that role versus Jacqueline has done it a couple times and loves it. So again, it's not, don't feel that there's kind of one way to do it or there's one right answer or, oh, if I don't work on this project, that's not really like data science. I sort of believe data science is really about, can you help people and companies make better decisions with data, whether that's by making a machine learning model in production, as we'll talk about a little bit later, or making an analysis or writing a report. Like really, these are all very, very valid ways if they're able to help other people.
Yeah, and I would also say you're probably, if your career is anything like mine, you are not going to get this right the first time. You're going to go work at Google and realize, that's too big of a company. You're going to work at one of these like little retailers, Handbag Love or whatever, and then realize, I wish I was at a place that was more technically sophisticated. It takes a lifetime to decide what you finally like doing, and that's okay. You're not a failure if you don't like your first job.
Yeah, I think there's definitely an iteration process here, and I think that's one of the nice things about data science. It is becoming true in other fields too, though, is that you're not necessarily expected to stay at one company forever. It's quite normal to switch, like within a year, a couple of years, especially if you're on working in a tech company, but even other industries. And so exactly like Jacqueline said, it's worth it to do some introspection. But at the end of the day, like going out and actually trying these jobs is, you may surprise yourself by finding something that you thought you wanted, you don't actually care about that much, or vice versa. It's something you're like, oh, I didn't think I liked this much. Actually, I love having this freedom to, yes, it comes with trade-off of being on a smaller team, but this means I get to make more decisions and get to be more involved.
Yeah.
Do the next one.
Yeah, I'll do it. So that was chapter 2. This next one, we're going to jump ahead. So we're in the, okay, you have a job as a data scientist, now what section? And so this is a chapter on chapter 11, which is putting data science into production. And I think, so I wrote this chapter. I thought it was one of the most challenging chapters to write just because it's so hard to know what people know and don't know. And so this is all about, okay, so let me give you 30-second intro. What is putting into production? So if you're a data scientist, one of the things you can do as data science is you can do analyses, reports, right? Where you're on your computer, you do some things, you learn some things, you put them into a PowerPoint, you show them to an executive. Putting something into production is, I'm going to write code, I'm going to make a model, train a model, something like that, and then I'm going to make that code run constantly, every day, every hour, in real time, whatever. But the point is the code is no longer runs once on your laptop. It's continuously run in some environment where we think it'll keep running and not break.
So this is like on Amazon, when you go and you look at, a book, you see like recommended other items, right? There's a recommendation algorithm that is running in the background, maybe millions of times a day to service those recommendations when people visit.
Yes. And like at T-Mobile, one of the things I was consulting for them and I helped do was help them build a model that every time you text T-Mobile's care center, the model will help look at what you're saying and try and use that information to help get the agent be able to help you faster. But okay, so this is a brief excerpt from this chapter on production, and it's called The Term Server. When you hear the word server, it can be intimidating, like some special computer that normal people don't understand. But in practice, a server is just an ordinary computer, such as a laptop, but it runs somewhere without a screen. Instead of walking up to a server and logging in, people connect remotely with other computers, which simulates being in front of it. Servers run almost the same operating systems as computer laptops, Windows or Linux with some minor tweaks, If you connect remotely to a server, it should look very familiar with the same start menu for Windows or terminal for Linux. The advantages of servers are that people can usually leave them running, and they tend to live in safer places than a home office. But there's a reason you couldn't take any old PC, there's no reason why you couldn't take any old home PC, put it in your closet, and treat it like a server. Many software engineering hobbyists do just that. When people talk about using cloud services like Amazon Web Services, Microsoft Azure, Google Cloud Platform, what they mean is that they're using servers that are rented from these companies. Just because you're paying a big company for these services doesn't mean these computers are different. You can think of them essentially as being expensive Sky laptops. And I think this section is important because I have been a data scientist for I think like 15 years now. And I think the first 10 years of my career, I did not know that. I was like, oh, I'm doing my stuff on my laptop, but oh, I don't know how to use servers, like production. And the more I started to eventually learn in the more recent parts of my career, the more I'm like, oh, this is just the same thing I've been doing the whole time. Why didn't I just play around with this from the beginning? And so actually having spent a little time where I went and I rented a server from Amazon and I tried running some code on it. And then eventually I learned Docker and all these things. Like it flowed very naturally, but I had to get past this intimidation I had as a data scientist of like, oh, I'm just a data scientist. I can't use these servers and things like that. And yeah, so I went from a person who was intimidated by the word server to at this point, like some of the code I've written is now being run in production. So enterprise companies are hitting it in real time still to this day. And that's really cool. And it's just the thing that like when you are learning to be a data scientist, don't feel like you should be intimidated, or like it is common to be intimidated by that, but don't let that stop you. It's still worth learning a lot of this stuff.
Yeah, I also like that example because there might be another data scientist, right, who say came from like a computer science background or was a software engineer, who for them it's server isn't intimidating at all, but then they're, someone says something about like Bayesian modeling and they're kind of like, oh, I've never done that. Like I've kind of heard that term. What is that? Because data science is such a broad field that it's impossible to know everything. And even if someone says like, oh, so for example, a professor, like say the best professor in the world on time series, right, may know nothing about another statistical area because, it's simply like they've specialized in this one thing and they haven't needed to know it. So I think with data science, it's easy to feel like, oh my God, there's like this huge laundry list of skills, all these things I need to know. But one, as Jacqueline found out with the server, it may not be as scary or as intimidating or time consuming to get those skills as you think. But two, you were I think it broadened more opportunities for you, but you were a successful data scientist for 10 years before touching a server. And like, yeah, once you learned, you got to do more stuff. But I think it just shows you don't feel like you're always going to be learning more. And it's okay. Yeah.
And there are probably more data science jobs that do not deal with production than do deal with production. That's what I would get. I have no actual data on this. I'm making it up, but it feels like there are actually more analyst, data science, decision-making kind of work than there is put a particular machine learning model into production kind of work.
Like I haven't put a machine learning model in production yet because it hasn't come up. What?
Yes, no, I was just going to say, when we say put a machine learning model in production, again, that sounds intimidating. But if you said do a logistic regression in an analysis, you'd be like, oh, I know how to do a logistic regression. But a logistic regression is machine learning. Taking a logistic regression, putting it on a server, making it run once a day, you just put machine learning into production. Like,
I don't know. I think that's AI in production, right?
What'd you say?
That's AI in production.
Oh, that's AI. That's right. Yes, exactly.
Excuse you. Yeah. Don't undersell me here.
Oh, I just saw in the comment, what if you don't know how to do that? I guess what I'm saying is it's not as hard to learn as you think. There's lots and lots of good guides of using AWS, Google Cloud, try getting a virtual machine and just getting your code to run there. Yes, there's like lots and lots and lots of guides, and you can read a lot of this stuff, and it's very much out there. So.
Yeah, I've also seen a trend too of even books that are available in hard copy, at least in the kind of our community. So Jacqueline and I are both in that community. More and more people are publishing it for free online along with the physical copy. So I've been reading one on feature engineering, which is actually language agnostic. So yeah, I think I think that can also be intimidating, at least for me, because sometimes it's like, well, yeah, everything's at my fingertips, but like there's so much of it. And so I'm also a fan of, you all are now in school and sort of formal classes, but once you get out of, I think there is something to be said for something called like just-in-time learning of, figuring out, okay, what am I missing? What resources are available? And, not worrying of like, okay, I must tackle everything before I can do anything, but thinking, all right, what are the next steps I need to learn, to do this project, to get comfortable with that, and not feeling like you need to boil the ocean.
Yeah, and I would say for putting things into production specifically, if you want to put R into production, me and Heather Nolis have a whole website, putrinprod.com, where we have blog posts and things like that, where we talk about like getting your first API. Like, what's an API? You can make one in R and put it in the cloud. It's all really cool and stuff. Yeah, I feel like that's all I got to say about that.
Yeah, I also saw someone mention pandas. Yes, that's I presumably, I'm assuming that's for Python pandas. I don't know what you all will eventually learn in terms of.
Also, I hear your animal now. It's not just my cat. Haha.
Yes, hi again. He's wandering around somewhere. Michael's taking a nap. Okay, so Jacqueline's probably going to make fun of me because I'm going to read not what we wrote, but what one of our interviewees that we have at the end of every chapter spoke. So yeah, as I was saying, so we have 16 chapters. At the end of each one, we talk to a real live data scientist. So people working at Airbnb and Google as engineering managers, as directors, as, just like a more junior data scientist who's entered a few years in. So this is the end of chapter 12, which is working with stakeholders. Sadie Snowden at Akintunde. So she works at Etsy, specializing in experiment design analysis. And we asked her, why is managing stakeholders important? And before I start, so a stakeholder here, we talked through the chapter. This is basically most data science teams don't work in a vacuum. So your stakeholders might be the, when I was at Etsy, it was the search team that I worked with. So I was helping them design experiments. It could be engineers. So maybe engineers that you're working with to put your model in production. It could be higher level business people if you're presenting to an executive. So it's really quite a range. And so we ask her, why is managing stakeholders important? And she says, unfortunately, it doesn't matter how smart you are if you cannot communicate concepts to non-technical stakeholders. At the end of the day, a lot of these companies are run by people who may not have the same level of technical skill as you. You need to be able to communicate to them in a way that both makes them feel capable and allows you to advocate for yourself if necessary. Managing stakeholders is probably one of the most important aspects of data science, but it's often highlighted the least. Then I also want to read her answer to our last question, which is, what's your final piece of advice for junior or aspiring data scientists? Where she says, I think that people tend to want to go into technical careers like data science because they think that you can focus only on the logical element and not deal with the human element. But that's not the case at all. When people are considering a career in data science, they should really think about if they are willing to have a small ego in order to communicate and do their job well. It's really easy to say, I want to learn how to build this model, and I want to learn A/B testing, and I want to learn all the technical things. Well, that's great. The soft skills are what are going to take you far in your career. So what are your thoughts on that, Jacqueline?
I will say I agree with all of it, of course. All of our interviews were great. I will also say that I think that it's like the skills matter the most for these soft skills because those problems show up the most. Like look, I do a lot of data science on a day-to-day basis. My problems are rarely, I can't get the model to fit. It's that. It's like, oh wow, like I'm having trouble because this team's code doesn't integrate with my stuff, or like, hey, the presentation isn't aligning with the stakeholders' interests. It's like there's so much more of the work in data science is with the people part than with the, you didn't use a neural network, you used logistic regression, so the model isn't good enough. Like that's, at least for me, like I found that just much less of my job. Yeah.
And I think that's partly because with some technical issues, right, there's a proven solution that you can go find online, right? You're like, okay, I need to make this kind of plot and it has to be color coded this way in ggplot. And you sort of Google and there you go, Stack Overflow like prints out to solve it. But while there are courses and practice and stuff you can take that will help you grow your communication skills, you can't just Google and be like, so here's my exact situation with this stakeholder and they're not doing this. Like you're not gonna find an answer there, which is I think one of the reasons it is a little bit more challenging is because these come up in so many different unique situations. And I like Sadie pointing this out because I do think that it can be something frustrating, especially if you have, kind of say in school focused really on the technical parts and, really thought like, okay, as a data scientist, I'll just get to like hide in my room and like work on, my computer and like show my models, and everyone will think it's amazing because I did this newest thing that I just learned on Kaggle about like how to build a neural network, and you might get annoyed because like, oh, that person who like I feel isn't technically as skilled as me, like seems to be being promoted or get their work used more. And that's, it's technical skills are having a certain level is certainly table stakes. But as Sadie says, I do think what ends up, especially further in your career, that can differentiate you, or on the other hand, hold you back, is if you don't have the kind of soft skills of, communicating and working with stakeholders.
Yeah. Can I actually give an example? I think like just a very concrete example of data science isn't the hard part. So let's say you are at a company and you're working in the, in the marketing department, let's say the customer care department, and you have 500,000 emails you've received from your customers with complaints. And you've been asked, hey, we want you to make a machine learning model that classifies these into some categories that we can use. So you like group, these are all the complaints about the price. These are all the complaints about the product not working, blah, blah, blah. And you're like, all right, sure, data science. That's very data science. I'm going to build a classifier model, blah, blah, blah. And then you're like, wait, hold on. What are the groups I should classify these into? Do I let the model pick? There's some unsupervised learning where the model just picks things. But then like the model, if you're like a car company, you never know. The model might just put everything into one car group. And like, that's not practical for the business. You're like, okay, I probably want to talk to the stakeholders. Like, well, what groups do you want to do? And then they say, well, it depends. And it turns out it's this whole discussion of like, well, the real core question is like, well, what do you want to use these groups for? Are you going to email them differently? Are you needing them to connect to the reporting that the other teams are doing? And like that whole negotiation is way harder than building the model that actually does the work, in my professional opinion. So I think, I just think that's like a very clear example. And that being said, so Emily, so how do you get good at this? How do you get good at Skateboarder? Yeah.
Well, first you watch Jacqueline's talk, which I'm posting in the chat, called You're Not Paid to Model, which is a more extensive example of all the steps before you get to like, doing was it prediction modeling?
Yeah, it was like basically what I just said in a 20-minute rant, which is good though. It's a fun time. Yeah.
With lots of examples. Yes. So how do you get good at this? I think actually what helped me was I did a fair amount of extracurriculars in college, including student government. And I think getting comfortable speaking in front of people, sort of these negotiations that happen in meetings was really helpful. Written communication, like I'm sure there's a lot of classes that you have available, around that. I think that's also like learning how, even if you're not writing, you're not going to be writing most of the time formal essays, and you're not going to be writing a literature review. The time is running around. Okay, Yeti. I'll pick him up after I'm done, so you can all admire him. So I think classes are good. Also, honestly, some of it is just practice. Like we have a whole chapter on failure, and you'll probably make mistakes, right? You'll go afterward and you'll be like, wow, this process ended up not going well, or the project failed. And I think part of it is learning to reflect and learn from other people who are modeling it. But Jacqueline, how did you get better at it?
Well, I will say this, it's by being bad at it a lot. I don't know, like I keep messing stuff up, and I'm like, I probably shouldn't have said that in that meeting, in front of everyone, or there's just a lot of trial and error. And I think you eventually kind of learn like, hey, when I said this in that meeting, that really resonated with everyone, versus, hey, when I said that in the meeting, everyone got kind of upset and it was a chaotic meeting for the rest of the time. We didn't go anywhere. So it's really just like, this isn't helpful, but it's really, I think a lot of this is just learning and taking your time with it. And so don't expect that you're suddenly going to walk into the boardroom day one and nice. You're going to walk into the boardroom day one and suddenly be the best at dealing with stakeholders.
Jason claimed that you all liked when his cat appeared, so I thought you might also appreciate a dog.
He's big now. Wow.
He's only 30 pounds. He's just very fluffy. He's just fluffy. Yeah, I like people saying that they love him. He's so cute. Yes, he loves everyone. He's the friendliest puppy. It's not very good for social distancing, though.
So he's your stakeholder. How would you do that?
Yeah, I assume is Magic your cat, Jason? The people are demanding an appearance. There's also another dog underneath me, but she is 13 and more reticent versus he's like a year.
Yeah.
Anyway,
cats don't come on command, so.
Yes. Sorry, we got a little off topic, but yes, trial and error. But that being said, I do think like one thing I am glad, again, looking back at college, was I wasn't just like, all I'm going to do is spend all my time in classes or on homework and like take all the technical stuff and like just really focus on those skills. Like those are important, but I'm glad, I think I did build up other important skills by doing things like extracurriculars or taking other types of classes. So I'm really glad I took the time to do that.
Yeah, I think for me, it was college improv.
Yeah.
That like so much of college improv actually helped me for I'm giving a technical presentation in front of a bunch of people and someone just asked me a question. Like that's like improv a little.
Okay.
So
Should we take questions now, Jacqueline?
I feel like we have discussed these three things well. So yeah.
Excellent. Thank you. So just a reminder for everybody, if you want to ask a question verbally, please use the hand raise. And also the stuff in the chat, I think that looks like I can do some wrangling. And if Jacqueline, Emily, if you see a question in the chat that you want to go after, please feel free before I even say anything.
Okay.
So, all right. So we have Gil is ready up. So Gil, do you want to go?
Yeah. So like from podcasts that I've listened to and from several people I've spoken to, it seems that the general term of data scientist has recently been splitting into kind of these subfields such as data visualization, machine learning, analyst, business intelligence, and roles like that. Could you maybe talk a little bit about that and kind of maybe give your opinion or prediction about whether data scientists will last as a general career or whether it will continue to split up?
Yeah, I can take this one. So I think some of the ones you've mentioned, I think that what you're saying is kind of like it is both true and not true. So I think in the sense I think there's really three core things. There is, and we talk about this in the book, there is an analyst, and an analyst just takes data, turns it into reports, gives it to people to do stuff with. So they don't really like make inferences, they just get the data to where it needs to be. There are decision scientists, which is now kind of becoming just data scientist. And a decision scientist or a data scientist who takes data and uses modeling and all this to make a business insight, like, hey, we shouldn't build a factory here, or hey, this product isn't doing as well as we expected. And then there's a machine learning engineer, which is the stuff I kind of talked about in my section, which is like, I will write code that runs every day and powers a recommendation engine and all that stuff. I think those are becoming more distinct each day. Like, I think that's true. I think it's very possible to switch between them. Like, I think I arguably started as a data scientist and have recently become more of a machine learning engineer. Some of the stuff, like I like a data visualization expert, those kind of exist, but there's like 10 of them. Like that's like a really niche job. If you think like analysts, there's probably like 2 million. Data scientists, they're probably like 200,000. Machine learning engineer, there's probably like 100,000, something like that. Like it's just like they're not evenly bucketed.
Yeah, and I will just add for that that I do think one thing I am appreciating actually is more people putting like Airbnb has done this, like a comma after data scientist. So like data scientist, comma inference, data scientist, comma analytics, because you can have at two different companies, like a position that's they're both called data scientists, they're both called data analysts, and they are totally different. So there's definitely not at the point where there's standardization in these titles. Like research scientist is a new thing too, which is like PhD level research. And I'll also add data scientist, I think, is starting to become not a entry level title. So I think I haven't seen as many like coming out of college or master's degrees, data science position. I think it's more common to have like data analyst or other different titles there.
So yeah, I guess I didn't understand this work. Jason, do you want to?
No, that's cool.
Okay.
No, so I was going to mention that Kaika is next up. If you want to go.
Hello. Thank you so much for accepting the guest lecture. It's really good to have that experience, as Professor mentioned before in lecture. I have a question. I think it's more for Jacqueline. I know you are a mathematician too, and I am a math major. What make you choose data science? Because I'm trying to find my niche inside of math and computer science.
Oh yeah. Okay. This is oddly targeted, well targeted at me. Here's my problem with the field of mathematics. So my PhD is not in mathematics. It's in operations research, which is what kind of math. The problem with mathematics is mathematics, like at its core, is about proving theorems. But there aren't just theorems in the world to prove. Like you don't get hired by Google because they have all these theorems. And like I actually, as a math major, thought when I went out, and this is like 15 years ago, when I went out to go get a job in the real world, I would get hired to like prove math theorems and stuff. And that's just not there. What is there is, hey, I have these massive amounts of data and I want to know something about it. I want to make some insights, but I don't necessarily need to prove something for certain is true or false. And math is similar to that, this idea of taking numbers and data and saying stuff, but without the rigor of it has to be 100% true or false before I can claim it's valid. And I found that very constraining, which is why I left the field of mathematics. But I like it. I mean, it was a good time, but I think ultimately why I'm now a data scientist and not a mathematician.
Thank you so much. So I have a couple of chat questions that all seem to be falling in relatively the same region of internships. So, what's the importance of internships? How do you go about getting them? If you're a junior looking for a DS internship, how would you go about doing that with very little coding experience? There's several in that vein. So maybe you guys want to take a swing at that one.
Yeah, so I'll start out by saying I think one challenge can be, and we talk about this for your regular job search as well, is like really focused on like, it must be like a data science internship, must be like a data science department. Because one, there just aren't that many of them. Two, they more often are for like master's or PhD students. So I remember talking to someone like a fellow alumni who worked at Indeed, and she said like her department hires interns, but they're not the data science part. They're like business intelligence, and they do programming stuff. But she's like, yeah, the students never seem that interested in that. They all want to go to like be the data science. So one, I would say if you can broaden your horizons and be like, okay, will this get me practice working with data? Because even if it's not called data science, even if you're doing like what analytics work, you're going to learn so much about like how like it really works at companies, how complicated data can be, like all these like legacy systems. And I think that's just going to be really valuable, and not worrying so much of like, oh, I got to work at like top brand name company, or on a really complicated modeling project.
Yeah, and I will say this, I think that the point of an internship in practice is, hey, when you're applying to a full-time job, you want people to look at your resume and be like, oh, you have a basic understanding of how to get a technical project, a open-ended technical project done. Because look, you've been in an internship, you've done some stuff. So we trust that you've gotten over that hurdle of like, how do I work on a thing on my own and not just like get an A on a test. An internship is not the only way to do that. Another way that I think is kind of becoming more important in this field is just doing side projects. So like, you have some time over the summer or whatever, get a data set online, build a model on it, make some charts, do a blog post about it. Me and Emily have a bunch of examples about this. The most recent one I did was about lazy river tubing in Arizona, and doing a model on that. Like there's all sorts of stuff. And just having some example of like, look, I had a data set, I had a question I wanted to answer, and I used the data to answer the question or do whatever. Having that can be really, really valuable. And you can put that on your resume in the like related experience. You can list that project. And I think that often works quite well. So, So less than trying to like, here's how you get those hard to get internships. Like here's a viable alternative, I would say.
And also that the other part, especially if you haven't worked in like a more corporate job before, is like, will they show up at the office every day and like be a decent person to interact with? So like if you got a consulting internship, or like I did one through a leadership program after my sophomore year in college. Sorry, that's the dog. And I like a governing magazine. And I think that was, even though it wasn't neither of those were data science internships, they were still valuable to show, look, I have some like work experience in a corporate environment. And when you pair that with like technical side projects, I think that gets you a lot of the way there.
Yeah.
Excellent. Very cool. So I think Matthew is next up to ask a verbal question. You ready to go, Matthew?
Yeah, I'm ready. Hi. So, I mean, I asked this question in the chat too, but I guess I can ask it here as well. So I know you mentioned earlier that like as you start off, like as you start looking for a job and throughout your career, like you're likely you can like start like hopping from place to place, because eventually you find like, okay, like maybe like I don't really enjoy like this kind of job, this kind of data science job, so I guess I'll move to like Airbnb or like move to like Google or whatnot. If you end up do like hopping from place to place, like do you end up having to like, learn new skills as you move? Like for example, like I'm interested in getting a job working for Major League Baseball, but like for all I know, I could end up working for like Airbnb or something.
So For full disclosure, I've had lots of jobs. I've only had one job that I've been at for more than 2 years, and it's 2 years and 1 month sort of a thing. So like I jump around a lot. I think you both do have to get your skills to change a lot, and you also don't. Because like on the one hand, at the end of the day, you're always going to load up a data set, summarize it, put into a chart. Like a lot of the stuff, regardless if it's the Airbnb or the a sports league or whatever, a lot of the stuff's kind of the exact same. But then at each job, you will probably have to learn something new. Like at this job I have right now, this is the first job that I was on a team that was all Python users. Before that, everything I'd done is pure R, and it was great. So it's like, okay, great. The first month of my time here, I was learning a lot of Python, and it was not a big deal. I don't think there's really almost any, you need to learn it before you should even apply for this job. Like usually if the job is a good fit for you, you will learn it there. But it's not like, yeah, so it's like you do a lot of what you have transfers, some of the stuff changes, but you'll learn it naturally. You won't like have to study before the interview. It's usually like they know you're gonna have to learn it on the job, and that's fine.
Awesome. So I have a couple of chat questions that I want to throw out at you. Daphne asks a pretty interesting one, kind of a left turn from where we've been going. How do you overcome the initial fear of making major mistakes when pursuing intimidating careers or projects? And more importantly, how have you learned to be okay with making mistakes?
Is therapy an answer? Yes, therapy, if you have, I don't know what the situation is UC is, but seriously, if you have college counseling available, I recommend it. But no, so we have a chapter on this, like making big failures. And I think I want to add one thing here, that your environment is important. So there's something called psychological safety, which is basically like you're in an environment where you feel like you can make mistakes and it will be okay and you won't be punished for it. And ideally, the environments that you are in are like that. And, in terms of like a classroom or a work environment. So I will say part of it is trying to find places like that where you can honestly see it modeled a little bit. And you can see that, like, if you give a wrong answer in class, you're not ridiculed, but other people, work to help you out, and other people take those risks. But I would say for me, what's helped is like, so Jacqueline was writing the failure chapter, and, sort of like all these examples, like, so in the book, we don't really talk much about our personal experience, but these were, they came from her own personal experience. I realized, I actually haven't failed that much. And it's not because I'm such an amazing data scientist. It's because I haven't taken a lot of risks. I've done things that have been more in my comfort zone. And that does start holding you back because it keeps you, from trying new things, from learning and growing. So I don't know if I have a great answer, but at least doing some self-reflection and really trying to be honest with yourself. Okay, am I in an environment that, if I objectively look at it, is something that is psychologically safe, I'll be accepted. And then just trying it out a little bit. So maybe not doing a huge major risk, but trying out a little bit of a risk, kind of recording like, oh, maybe that went better than you thought. It wasn't as risky as you thought. Or like, yeah, okay, I didn't mess up, but it's okay. And the world didn't explode.
Yeah, so as Emily said, just to be clear, we have an entire chapter on this whole concept of how do you handle failure, because this is how important it is as a data scientist. And yeah, just because so much of this job is you're going to take data and you hope something is true or false, but you don't know if the data will be able to show that. And sometimes you try taking your data and your model doesn't fit. There's no signal in there, or you can't find the data in the first place, or your stakeholders don't end up wanting it. Like there's so many, it's if you think about it, it is mind-boggling that not everything fails, that sometimes things work. And so when you shift to that mindset of like, oh, it's actually surprising that we would ever get a success, I think, yeah, some of the stuff Emily's talking about gets a little easier.
That is super valuable. Thank you very much there. So I think next up on the question is Chongyan. You ready to talk?
Yes, sir. So first of all, just thank you for attending this guest lecture. I have, I guess, like 2 questions to really ask. So me and my friend was talking about, so he says right now he's a senior at UCLA, and he was telling him about all the job titles that are named either data scientist or data analyst are usually, the requirements are usually going towards PhD or a master degrees. So if it's like that, I just wanted to know if that's the true case. And then as an undergraduate like us, how do we stand out? And also, if it's really the case, what are other job title or job description that when we go and look out for is it's related to a data science field.
I think one option is if there's a domain you're interested in. So for example, you're like, oh, I'm really interested in marketing. You could look for something like a marketing analyst position. I saw someone mention about startups, and I actually agree with that. So at the last startup I worked from, we had 3 people. One did actually have a PhD, but 3 people switch into being a data scientist, because just at startups, like there's less of this, bureaucracy and sort of like, titles mean exactly this thing. So basically it was people who, one case, it was someone working in sales, and they started getting more data science skills. They were taking classes online, they were making a sales dashboard, and they eventually were able to end up sort of transitioning, which is actually not that big a transition, to being a sales data scientist. And I think once you have that experience, in a couple of years, the degrees really start mattering a lot less in terms of looking for jobs. So even a job that might say it needs a master's, if you can show, hey, I have like 4 years of really relevant experience, maybe at a similar company or doing similar types of data science problems, your lack of degree won't matter that much.
Yeah, and I will just to be very precise, I would say there are jobs that require a master's, and I kind of see why. Like, I don't fully agree with it, but I kind of get why they're looking for someone with a master's, because you do learn more than you would learn in an undergraduate program. Like, okay, sure. But a PhD, if a job has a PhD requirement on it, it's either the 1 in 100 or 1 in 1,000 jobs that is actually a research job, in which case you definitely should not be applying for that unless you want to spend your whole life as a researcher. Or it's a company that doesn't really know what they want, and they think, I want a smart person, I'll ask for a PhD. And you don't also want to work there, because that company is not really sure what they want. They probably aren't going to be you're not going to have a good manager, things like that. Just be that's a huge red flag. So you don't need a PhD to be a PhD. You don't need a PhD to be a data scientist. I have a PhD, and I feel comfortable saying that. In ways, a PhD hurts you. It is harder to be a good data scientist because you have to unlearn a lot of stuff you do from grad school. So don't feel like, well, I really like this stuff, so the first thing I need to do is spend 6 years in academia doing research, then I can be a data scientist. That's not really.
I'm curious, what kind of things did you feel like you had to unlearn from your research career?
So a thing about a PhD is you spend 6 years or whatever, 10 years, depending on your PhD, you spend a bunch of years trying to really hyper focus on, I'm going to find this new, interesting, novel thing. I'm going to prove it is truly the case or not in one particular instance, and I'm going to publish that, right? Like my dissertation was I found a new algorithm for electric vehicles. I'm going to put that research. So people who have a PhD program, they're really thinking about, I need to get the very, very, very best algorithm, and I'm going to spend a ton of time thinking about it. And in data science and industries, almost always get the first thing that works, get it done fast, and move on to the next thing. And people who do things the first way really don't like shifting to the other way. That's never an easy transition. And so, yeah, it's just a lot of work.
Excellent. Yeah, optimizers versus satisficers.
Yes, exactly. That's the word I had in my head when I was saying this, satisficing. Yeah.
Cool. All right. Well, thank you for that, Jacqueline. So along the lines of getting jobs, Eugene had a question about interviews and the technical challenge questions. What kinds of technical questions do people ask? And is it similar to how programming interviews happen with plain old computer science?
So we have in our appendix of our book, we have 40 questions that are reasonable questions you should expect on a data science interview. And so I would encourage you to go check that book out if you want specific examples of kind of questions. It's generally not the CS kind of make a binary tree that sorts a blah, blah, blah kind of data. It's less of that. It's more something like describe a linear regression to an executive, or suppose you have the SQL table, what kind of a query would you do on it? Or what are the problems with using a neural network? It's kind of that more theoretical technical questions, more talking it out than writing the exact right answer or not. But it really depends on the company.
Yeah, I know. So we have a podcast in parallel to the book, which we just released the 7th episode on, which is the one on interviews. And one thing we mentioned there too is this does Jacqueline said, it's not that common to have these software engineering questions. It's possible. And the range of data science interview questions is just so broad, just like data science itself. some are good, some are not that good. And that's why we really recommend, if you're interviewing at a company, you can ask. So they won't tell you, of course, like this is the exact question we'll ask you, but they should say like, oh, okay, your first interview will be with an engineer, and they'll like work on a case study with you. And then the next one will be, a data scientist, and you'll do some SQL queries with a laptop, so on and so forth, because that can help guide your learning. And I think, it's worth kind of brushing up on your skills in general, but I wouldn't like do the whole cracking the coding interview, because that may never come up in any of your interviews.
Yeah. And I also, I hesitate to say this, but like, I would not necessarily feel like you need a super study for this interview, because if it's a company where it's like, we're going to ask you some peculiarity about some second moment of a probability distribution. If it's a company that thinks that stuff's important, you don't memorize it, and they're like, you didn't know it, so you're not a good data scientist. Like, that's not maybe a company you want to work at either. Like, just like, yeah, I don't know. I have some bitterness maybe from years of those sorts of questions.
Yeah, and I think there's other preparation you do. Like, for one thing, I recommend for behavioral interviews that it's a little less common, I think, coming out of undergrad, because you don't have usually a lot of work experience, but these types of questions are like, tell me about a time when X. And I think it actually is helpful to spend time before and thinking like, okay, what are a few interesting like moments or, my careers that I could use for these types of stories, versus being put on the spot and being like, oh God, when have I ever made a mistake? But yeah, I agree with Jacqueline. I hate these like, derive the mean function of it's just like all these things that are, you're never actually going to use on your job.
After all that, I kind of have this kind of like, bro, do you even data science kind of meme stuff going around in my head.
Yeah.
All right. Awesome. Thank you. It looks like Gil's back with another question. You ready, Gil?
Yeah. So I've kind of gotten various degrees of advice in regards to whether going to grad school is a good idea. And in particular, kind of the master's versus PhD debate, in the sense where many people will say you learn absolutely nothing during your master's, and many will say that you over-specialize in your PhD, and the master's is kind of the way to go. So in regard to being a data scientist, what's your opinion on that issue?
Don't do a PhD. Don't do it. Don't do it. Don't do it. Jacqueline, I have very strong feelings on this. So why do I say don't do it? It's super long. It's very intensive. Depending on what kind of department you are, they may be really focused on getting you through to academia. And so they will not accept that you want to go into industry. So you're going to have to like hide what you want to do. But that also means you're not really doing stuff that's going to serve you when you go into industry. It's like you have to be very self-motivated, especially in the later years where you take no classes. So I left my PhD after 2 years with my master's, and that worked out well because I got it paid for a master's with a stipend. But I am very glad I didn't. Like, just to complete it, you really have to be like research. Like, you really have to be focused on like just like a specific kind of question or field, and like read a ton of papers. It's just, I would not do it because I would only do it if you think you want to either become a professor or you really want to become like a researcher, like a research scientist somewhere, which is a pretty different position than a data scientist.
And here's what I will say. Okay, so I got a couple things to say. One, when I am interviewing, when I'm like looking at people to hire for my company, whichever company I've recently been at, what I generally look for is, hey, do you have an experience in doing something like data science? What I don't look for is your degree, right? Oh, you have a project, an internship. You worked at another data science company before. That stuff's great. And so if you go get a PhD, you spend 6 years, you finally finish your academic stuff, you have no internships or whatever because you're so busy focusing on your PhD, that's actually bad. You're in a worse place than the people who didn't get a PhD because they've had the last 6 years to go get relevant experience. And you might have liked it in the beginning. So I guess what I'm saying, and another thing, I really get worked up by this one. I know a lot of people who have masters and are like, I don't know why I got this. None of this information ended up being useful. I know a lot of people who don't have masters, who are like some of the best data scientists I know don't have master's degrees. But a lot of those same data scientists who don't have master's degrees are going and getting them because they feel like somehow they're inferior data scientists because they don't have masters. So it's so much less about the knowledge. It's so much more about the posturing / makes you feel better about yourself / kind of stuff. And like that stuff matters. It's real. But also don't overstudy and get a PhD and get all these master's degrees and trying to wait until you're super ready to then go into the real world. The faster you can start dipping your toes in, doing projects, getting internships, taking a year off and going and working, then going back. That stuff all really helps. And okay, last thing. I did my undergrad and master's, then worked for 2 years and then got a PhD. And I was so much better in my PhD program and I knew what I wanted because I had worked for a bit of time. Like there's nothing to say that if you don't get your master's right now, you never will. Like there's a lot of paths to this. Okay.
Oh wait, I want to add one last thing. Is like all master's degrees are not created equal. I'm sure there's a lot of people, like I did get, I was sort of on the way to a PhD, but I got value from it. And so yeah, maybe like, oh, this degree at this program, wow, they're like really not that good. But actually this other one is like, yeah, this fills in a gap. There were good classes. So I would say is I have a little bit less of like a universal opinion on, but I also like Jacqueline's point, because if you wait a few years, maybe your company will help you pay for it too.
Yeah, and so I'm curious. I'd like to ask a follow-up on all that. So for those of your colleagues who have been really great data scientists but didn't have the accreditation, right? They were still like highly technically proficient, right? How did they acquire that technical proficiency? Was it just on the job, or is it self-study, or combos, or?
It's so much. And I learned most of what I know. I learned this way is you're on a job and then suddenly they're like, hey, we need you to take all this text and classify it into different types of customer emails. You're like, I don't know how to do that. I'm going to go Google it. Oh, that's the thing called classification. I'm going to go read a book on that. Boop, boop, boom. Next thing you know, you're actually an expert in that field, right? Like that process, that's how they got good at this sort of stuff. And that's how, even if you get a master's and PhD, most of the stuff you'll actually learn in this way, not from what you learn in your classes, I would say. Yeah.
Awesome. Thank you very much. Yeah. So the question I raised is because, of course, all data science requires quite, intricate technical knowledge, right? Understanding math and theory in some respect is required. So that's where it's like, I saw a question scrolling by at various points about people interested in like, online study, like doing Coursera and Udemy and stuff like that, right? So I was very curious about like how people are pursuing it when they're in industry, if it's all self-study or if they're finding online courses to get technically proficient, that kind of stuff.
I think it's usually, most of it, I would say, is self-motivated. Hey, I need to learn this thing. I'm going to go Google it, read Stack Overflow, read blog posts. Like I learned all of deep learning, which I'm now pretty well known in the R community for being good at. I learned all of it just from trying it out, using it on a job. It didn't work. Oh, I got to fix it. Made it work. Now I know how this stuff works. Like rather than like, I've taken no Udemy courses on deep learning or anything like that. So
cool. Thank you. Thank you very much. All right, let's see. Let me go back.
I think you muted yourself.
Okay, I thought it was my headphones and I started looking around.
No, Jason, you're muted.
Thank you. I just forgot that I muted myself again. Yep. Yeah. All right, so it looks like next up is Goyen. Are you ready, dude? Goyen, are you ready, dude?
My bad. Sorry about that.
No problems.
Given the prevalence of betting models, how do you exactly decide what variables you give statistical weight to and which variables you toss out?
Oh, I like this question. And can I take this question? I like this question. This is question. So here's the thing about data science and industry is I would say in academia, where you're learning, you really have to think about like, well, how do you decide which features are important? How do you take them in and how to take you out? But like hey, I just need a model to work to satisfy, just throw them all in. It's fine. And like, but what if they're correlated? What are some problems? Like whatever, it proves the objective we need, which is to say, I mean, I think at times there is like hey, we're going to reduce the dimensionalities of the features for various reasons. We do need to account for this. But by and large, like that sort of question you ask is I think it's actually kind of an example of the thing that like, this isn't how, like, this is like, that's not the problem people have in industry, right? Because we just throw all the stuff in there and it's fine and it works. The problems we have are, hey, how do we know we're fitting to the right variable in the first place, right? Like, how do we know what we're trying to predict is the right thing to predict? Or Or, hey, if like, let's say all these features that we're putting in are based on the transactions customers are making, how do we know that data is actually correct and that we aren't including like return transactions or things like that? These sorts of questions about, is the problem the correct problem? Is the data the correct thing? Are we thinking about this in the right way? That sort of stuff is like 95% of our thinking in industry compared to the 5%, which is this of like, what is the optimal way to how to remove features? So you kind of walked into like a little bit of a thing you were expecting, but the short answer is like that question you asked, we don't really have it. I wouldn't say there's a standard answer. And I would also say that's not really like a thing people would think too deeply about, I would say. I don't know, Emily, you can counter me, but like that would be my hot take.
Yeah, I think that's, I mean, it also depends though. You have to understand the context, right? Is this something where it's basically we're looking for accuracy, like we just kind of care that it works, or are they going to want to interpret it because they're going to make a bunch of decisions based on like what we found predicts, you know, X, and then it does matter a little bit more about like the feature engineering stuff.
Yeah, and that's huge. This is such a huge thing in industry of, do I care about the prediction
Yeah,
or do I want to know, how to interpret it, why the model made that prediction, which is like a 10 times harder problem to get right, but also the thing like other stakeholders really care about. And like by default, you don't care about that. You just care about fitting the model most accurate. And so that sort of trade-off of like, hey, maybe I leave all the features in, but that allows for more explainability, like that, or like I take them out because it makes putting this in a PowerPoint presentation easier. Like that stuff really is surprisingly valuable.
I also just wanted, it's not really a question so much as a comment I see in the chat that I wanted to echo about like GPAs is GPAs do matter for getting into like a master or PhD. I think there's some companies where it matters like for your first job out of undergrad and then it never matters again. Like I have not had my GPA on my resume for years. I like even what college people went to. I don't know what college most of my coworkers went to, right? I don't know. It felt important to me when I was like applying to colleges in senior year of high school, but sometimes I find out and I'm like, I've never heard of that. And they're the best engineer I've ever worked for. And they work at like a, you know, pretty well-known company.
I would also say the field of your degree doesn't super matter. If you have a math degree, a CS degree, or data science degree, like, hey, that sounds vaguely technical. Cool, you're in. Like,
yeah, I will say like with that, like what Jacqueline's saying is like, if you sort of fall under the STEM umbrella, it is pretty common to see companies be like, we want like a technical or a STEM degree. Again, I think that starts mattering less if you have pretty directly relevant job experience, but that can't, I do think that's a real thing, at least for your first job, is there can be an advantage of having something that people perceive as more technical versus like an arts degree. Even if some of the best data scientists I know have liberal arts degrees and some of the best engineers, it took, you know, they did a little bit more of a winding path to get there.
Awesome. Thank you, guys. So we're coming up on 4. Do you have time for one more question or when do you want to cut off?
I could do one more, I think, and then I gotta go.
Yeah.
All right. So Isabel is waiting. Isabel, are you ready?
Yeah, I just realized you might have not seen the one in the chat, but I basically just wanted to ask if either of you have in mind some examples of some good places to work. Not so much like prestigious ones that like everyone's like, oh, you got an internship at Google, but more like just places that like maybe we haven't heard of or like really respect their employees and stuff like that.
I think that's like really good to be thinking of that. I think it's a little hard to answer because, you know, say we threw out like 3 names, right? Like maybe they have one data scientist position opening every year or something. And then it's like, there's like 300 of you. But I think things to look for me, when I kind of assess this is like something I've liked to come, like I work at Warby Parker now, and something I really like is they have like, this happened after I joined, but like the racial equity strategy, which is, you know, at the Black Lives Matter, the protests in June, you know, they really took a hard look at themselves and said, okay, you know, we are not where we want to be. And let's set some very specific goals in different areas. So some of that, one of the goals is around donations, but one of them is around increasing Black representation across the company. Another one is getting involved in, you know, increasing civic engagement and voter registration. So how do you kind of tell those values beforehand? You know, you can look at things like the human rights workplace, like places voted best places to work. You can, if you start getting involved in the data science community, you'll get to know people. Because this is also local too. Obviously, it's not that helpful if you really don't want to live in New York to know about a great New York company, although more are going remote. But that's why I think like getting involved in your local communities and meetups and stuff like that, maybe talking to alumni who are at the company, like getting the inside look from someone in a similar position to you is one of the best ways to really start getting an understanding of that.
Yeah, I would say most of the jobs, my best jobs and least favorite jobs, have nothing to do with the company. Is usually who is my manager. Like that's the thing that really changes if I like a job or not. But that said, if you like fit a line to all my jobs, I enjoy the job. I've enjoyed the jobs the least that have been in the most prestigious places. You know, like when you got like big tech companies and things like that. I just find it like the environment there is much less fun, interesting, open, whatever, than the smaller companies. Or like, you know, like I enjoyed consulting for T-Mobile, and that's not like a big tech company, but like that's also like, you know, that's still cool. Like being data science there is cool. Like I don't know. There's just I really like I have learned to like if a company's like, oh, it's Google, it's glamorous, all that, in my brain, like that is a negative, not a plus. And it took me a long time to learn that. And I guess that would be my one like when applying, if you're going to apply a Jacqueline filter, like -5 points if it's a company you think everyone would be impressed that you work at.
Yeah, I like that someone just posted that they low-key just want to work in a low-stress public sector job. I think that's so good to start thinking about for yourself. Like I remember, like, I don't know, I feel like a lot of young people in data science, right? It's kind of like, okay, I got to keep like moving and getting promotions and getting a higher salary and like, you know, doing all this stuff. But like, I remember talking to coworkers like, you know what? I've been here 4 years. I'd be really happy to stay here he's like in his 40 or so, like to stay here the rest of my career. Like, that's just what he wanted. He wanted, like, he liked it. He had like a good work-life balance. He had like an interesting problems, but it wasn't too stressful. Like, that's great. Like, don't let someone else dictate your career choices.
Whereas I had a job where I was working at a defense contractor, massive company, everything was super slow. Most of my day was just browsing the internet. By the end, I was like clawing at the walls, like, give me something. I need some work. So, yeah.
I think that was a great question to end on.
Yeah.
Yeah. Thanks, Isabel.
Well, thank you so much for coming, you two. We really appreciate your expertise. I want to plug to all the students once again that you guys have a book and that there's a podcast and these things are around. Emily, you had like a discount code that could be available for the students?
So
I
pasted it before in the chat. It's build book 40% symbol. And I'll paste, thank you everyone for your thank you notes. This might get lost, but we both have our blogs. One is hooked on .org. That's mine. And Jacqueline's, yours is jnolis.com.
Yep.
Sorry. Yeah. And we have our Twitters where we share some stuff. But yeah, I mean, I just want to end with thank you for mentioning the book again. Like, we did not write this book to like go get rich. We get like $1 each, or like if it's sold full price, like 50 cents is not. So, you know, we really wrote it because we hope that it could help people. Writing the book gave us like the time and space to think about it and the editing. So, you know, we mentioned it a bunch, but that's just because, you know, it was really formed by, you know, these very common questions. And we hope that and the podcast, which echoes the book, and our blogs and all these things can like really help you all out in this.
Yeah. Because we were both here where you are.
Yes,
we were there.
we were.
I was there. I remember the anxiety of being a college student, being like, what's going to happen next? And so
I like
this book, yeah.
Sorry, I saw someone joke the dog is like, you must buy the book. That's what the barking was about now. But yeah, I mean, thank you all for coming. And also, you know, I remember it's look, the other thing I'll last mention, people think about internships as jobs. Your first one is the hardest. It gets easier, I promise. Like, it is, you know, where you know, we talk about like building community, these different strategies you can to make it easier, but even actually later job searches are really stressful. So you will make it, you'll be okay. You'll find something interesting, even if not in your first one. And, you know, start is coming to lectures like this and attending this class.
Awesome.
Any chance I can see the dog again? No, my husband took it out. Hold on, I'll share the other, one sec. I'll share the other.
Emily. Well, thank you all.
Yeah.
Hey, I'm giving the people what they want.
Oh my goodness.
Emily, you are.
I want.
Yeah.
Someone said,
that's
"Oh my
pandering."
God.
That's what it is.
It is pandering. Are you kidding? If I was a professor, the dogs would make an appearance every day, and that's how I get rated well. Yeah, this is Abby, who's 13. Anyway, sorry everyone.
Very cute. All right. Well, thank you again, Emily, Jacqueline, Emily. You guys have been the best. We really appreciate it.
Yeah, thank you all.
Hasta, everybody.
Bye, everyone.